I just don't have access to the arguments because I don't have the parameters. But it's not like everything broke just because in the event I passed in the arguments. And lastly, I would just want to reiterate the point that even though you might not write your own events, events are a core building block of Node. And effectively, as you're building and writing out the code for your Node application, you are using those events at the end of the day anyway, because a lot of built in modules rely on them. And as a quick side note, if you'd like to see the code that we wrote in previous two lectures, you can just navigate to 13 event emitter. And in order to show you that, I'll quickly set up a server. And again, the code for this one you can find at 14 and then request event. So I'll copy all the contents from the file and then just copy and paste. And notice something interesting where again, yes, we're getting the HTTP module. And remember the setup that we have used so far, where we go with HTTP create server, and then we pass in this callback function. And then, of course, this callback function will be invoked every time someone visits our server. So every time the request comes in. Now, there's another way how we can set it up by using Event Emitter API. So we still create a server. We go with HTTP and then create server function. But instead of passing in the callback function, like we did previously, server has the method on. Does that ring a bell? Remember our previous example? We had our own instance and it had the method of on, correct? So the same goes for server. So server has the method on and we listen for request event. And when that request comes in, then of course, again, we have this callback function that handles it. So behind the scenes, server emits the request event. And then of course, we can listen for it. We can subscribe to it, listen for it, or respond to it, however you'd want to call it. And the way we do that, we go with server on, and then this is a specific name because of course it emits that specific name behind the scenes. So make sure that it is a request and then the same spiel. Now, how do I know that? Well, if we go to node documentation and if we look for HTTP, we keep on scrolling. Eventually we'll hit the server. And over here, I can see that it has a class. Okay, that's a good start. And then what do you see here? Well, I see the event, right? And what is the event? Well, the name is request. So that's how I know that my server, the instance that I create, has the ability to listen for request events. And if you want to dig deeper, you can just click on a server. You notice that it extends the net server. And if we keep on digging, check it out. So this one extends what? It extends the event emitter. So hopefully that makes it clear that even though you might not be setting up events on your own, a bunch of built-in modules rely heavily on this concept of events. All right. And up next, we have streams in Node.js. And at its simplest, streams are used to read or write sequentially. Basically, when we have to handle and manipulate streaming data, for example, continuous source or a big file, streams come in real handy. In Node, there are 4 different types of streams. We have writable, used to write data sequentially. Then we have readable, used to read data sequentially. Duplex, used to both read and write data sequentially. And also transform, where data can be modified when writing or reading. Just like with events, many built-in modules in Node implement streaming interface. And what's also interesting, streams extend event emitters class, which simply means that we can use events like data and on streams. Since streams are somewhat of an advanced topic in Node, I'll try to keep it short and sweet, mostly by showing you examples of streams, and hopefully that way you get the main idea without being overwhelmed. All right, and once we know the theory behind the streams, now let's take a look at the practical example. And a very good use case is using streams when we are reading files, because we need to understand one thing. where when we use the sync or asynchronous approach, what happens, we're reading the whole file. And of course, in our example, we were setting this equal to a variable, correct? But if we have a big file, well, first of all, you're just using all that memory. And second, as the file size gets bigger and bigger and bigger, eventually the variable is not going to be good enough. You will get an error that, the size is too big and you cannot place everything in the string. So, what would be a solution? Well, solution would be read stream option. And the way we'll set this up, I'm going to start app.js from the scratch. But if you take a look at the repo, you'll notice this 15 create big file. So previously, when we were working with files, I just had some small files, right? So I had the first txt, blah, 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 result, and whatever. Now, before we set up the read stream, I would want to create a big file. Again, this is optional. You don't have to do that. But in my case, in order to show you how the streams work, yes, I'll have to set up a big file. And first, I'll remove it because, of course, I already have it since I was testing it. And now I'll stop my server. And of course, in my case, I'll run 15, the create big file JS. If you want to set it on your own, and if you don't want to use the repo, you can just get the right file sync from the FS module. And then notice I have the loop where I believe I have here 10,000. And then every iteration, I just write a big txt. Of course, I have the flag append, and then I'm just adding hello world and starting a new line. So if I'll run node, and then of course, I'm going to go with my file name, which is 15, then hyphen create big file and JS, like so. Then in the content, I should have this big file. And once I have my big file, I'll go back to app.js and I'll use my npm start, since of course I have nodemon in place. And then let's go with const. Now, I'm not going to show you how the setup would look like with file sync or the asynchronous one. Again, hopefully you understand that the setup would be exactly the same like we have in 10 and 11, where we had the FA sync and FA async. And now, of course, let's just go with the stream option. So the method name is create read stream, and we require that from the FS module, like so. And then we create a new variable, and in my case, I'll call this stream, and we invoke the create read stream. And the only thing by default we need to pass in is the path. So, of course, in my case, I'm going to go with content and then /. And since I just created that text file, the big one, of course, I'm going to go with big txt. And now remember the good old friends events. Well, once we create this instance, we actually have access to them. And the ones that we're going to use is going to be data and error. So we can go with stream and then on. Again, remember the event syntax. And then the event that you would want to listen for is a data. And then we have our callback function. And again, it is a parameter, so we can call it whatever we would want. But in my case, I'm going to go with result. And let's just console log the result, like so. And what you'll notice is that we have 64 kilobytes here. That's our first console log. Then we have another one for 64 kilobytes. And the reason why I know that is because by default, that's the size we're getting. And then we're getting the reminder. Now, just to prove my point, I'm going to go to my folder and I'm going to look for my content. And then in there, if you take a look, the big text file we created is 169 kilobytes. So as you can see, now we're reading data in chunks. And by default, that chunk is 64 kilobytes. And every time we console log, we see that we have 64, 64, and eventually we have the remainder. So instead of reading everything and placing that in the variable, we're doing that in chunks. And as you can see, we're using the event and the event is data. And in order to hammer this home, why don't we take a look at the docs? So first, I'm going to look for my file system, and then let's look for our create read stream. So we go here, as we can see, we have this class, read stream. And then on this class, we have these three ones. We have close, open, and ready. And as a side note, we'll use this one a little bit later as well, the open one. So keep an eye on this one. And then as far as the read stream, well, as you can see, it is created when we go with create read stream and invoke it, right? So I got the create read stream. That's my function. I just passed in the path and I invoked it. And in turn, that returns the read stream, right? Then actual read stream extends from stream.readable. So right away, I have these events. I have close, open, and ready. And like I said, we'll use this open a little bit later. Now, since it is extending from the stream, check it out. Now, of course, I have the data one, right? So this is a chunk of data. And as you can see, every time we are getting that data, we can do something with it. Now, at the moment, we're just console logging. It's very simple. But eventually, as you can already imagine, we can do way more useful things than that. Beautiful. Once we understand the basics, now let's take a look at some additional info. Like I said, by default, the size of the buffer is going to be 64 kilobytes. However, we can also control it. And the way we do that is by passing in the object when we're setting up create read stream. So first argument is going to be the path, which again, in my case, is going to be that big text file that I created using my file, using my for loop. And then I can pass in the options object, and in there, the property that you're looking for, the property that controls the size of the buffer, has the name of high watermark. So for example, if I go with 90,000 here, then of course you'll see that I'll have two console logs, one for 90 kilobytes, and the second one will be remainder. Again, keep in mind that our file size is 169 kilobytes. That's number one. Number two, we can right away set up the encoding as well. So I go with comma, and then the property name is encoding. And again, we'll set it up equal to UTF-8, like so. And then you'll see in the console, of course, the hello worlds. Why? Well, because that is the content coming from the file. And lastly, I also would want to mention that we have the error event as well. So if I go with stream and then on, and we're checking for the error, and as always, we can do something once that error happens. So that's our callback function. And in this case, I'll just access the error property and I'll console log the error. So I'll say here error. And the way we check that one out is by providing wrong path. So in my case, I'm just going to add 2 dots. And then once I save, check it out. In the console, I'll have the error where it tells me that no such file or directory. All right, and now let's take a look at the practical example when streams come in handy. Now, again, this is going to be one of those videos where you don't have to code along. You can just sit back and relax and see how I struggle. And first, what I would want is to make it even a bigger file. So remember the 15, create big file. I believe I had 10 iterations, right? So I'm going to add one more, meaning I'll add one more 0. I'll stop my server right now. Again, this is optional. You don't have to do that. And I'll remove the big file like so. And then I'll run one more time the file with node. And then, of course, this file is going to be way bigger. So let me navigate to my folder just to showcase that. And I'm looking for content. And now the big file is 1.8 megs. Now, once I have the big file, I'll go with npm start. At the moment, I just have the stream example. But if you want to see the whole code, just take a look at the file number 17. And notice again, we're creating a HTTP server, and I'm just using the read file sync method. I'm looking for big txt. The encoding is UTF-8. And then I just place my variable, my text one, into res.end method. And effectively, I'm just sending my big text file. And let me restart the server here. So let me go with npm start right now. So let me select everything from this file and copy and paste. And now if we navigate to localhost 5000, we should see a bunch of hello worlds. Now, the problem with this setup is following, where if I go to developer tools and if I take a look at the network and if I refresh, yep, this request was successful. Take a look at the size. Do you think it is the smartest thing to send these type of files over the wire? And of course, this is just going to make it very difficult to all your users because you're just sending large chunks of data. Effectively, I'm sending the whole file. And more specifically, if I click, check it out. So I have the request URL. Okay, that is good. The method is get. Now, as you can see, the content length is my 1.8 megs, right? And you'll see in a second that once we refactor this to read stream method, that we're sending data in the chunks. And again, the best way to see that is by looking at the headers, where at the moment I can see the content length, and that one is at 1.8 megs. But once we refactor that, the setup is going to be different. So at the moment, I have this text. I'm accessing that by read file sync. So comment this out, and let's set it up with our create read stream. So I'll go with const, and I'll call this file stream, and this is going to be equal to fs, and then create read stream. Now I'll use the same address, so I'll use the same path, and then I'll use the same encoding as well. So let's go with UTF-8. Okay, awesome. And once we set up the stream, remember we have access to two events, file stream on, and of course I'm going to be looking for the open, and I'll have my callback function, and we'll set that functionality up in a second. And the second one, of course, is the error. So I'll go with file stream and then on. And again, we're looking for the event by the name of error. And then in our callback function, we can access the error, and I'll simply pass it in my response. So if there is an error, I'll just grab the error from my parameter and pass it in. Now, as far as the open here, instead of setting it equal to, instead of going res.end and then text, file stream also have the pipe method. So we can go with file stream and then pipe. And what the pipe is doing, it is pushing from the read stream into write stream. So you can imagine that if we can read data in chunks, we can also write data in chunks. And what happens under the hood, a response object can be set up as a writable stream. So we have our file stream, so that's our read stream. We have method of pipe, so we're piping this into a writable stream. And now, of course, I'll pass in my response object. And if we go back to the browser and if we'll refresh, now notice something interesting. Yeah, still same request, right? To localhost 5000, still same size. But if I take a look at the headers, now I can see that my response headers are chunked. So instead of sending our file back in one large instance, we're sending it back in chunks. Awesome. Congrats on completing section number 3, Node Fundamentals. And hopefully after watching the section, you have a good general understanding of how Node works. And now that we're big shots, let's apply that knowledge and build some servers, shall we? And we're going to start section 4 with the general info of how the web works. More specifically, how we exchange data on the web. And we're going to do that with the help of a few slides. Now, if you're one of the people who's already reached a daily slide limit, I hear you. Once we're done with these suckers, I promise we'll mostly actually write code for the remainder of the course. I do believe, though, that before we build an actual web server, it's crucial for us to understand how it works under the hood. And that way we'll have clearer understanding of what tasks need to be done. If something is iffy, you can always go back to the slides you already know where they're located. And also, as we're going to be progressing with the course, from time to time, I will swing back to them when I'll need to emphasize a specific point. With that said, let's talk about how we exchange data on the web. It's safe to say that if you're watching this video, you know how to use a web browser. But under the hood, the way it works, every time we open up a browser and we type the URL, so the web address, we're actually performing a request. And we are performing a request to the server that is responsible serving those resources. So, for example, when you look for CNN.com, you're looking for the server that has those resources, and then that server sends you back the response. And the same works with YouTube, the same works with johnsmilk.com or whatever. So you just pick a resource, you say, hey, can I get this data? And then server who is responsible for those resources just sends you back the response. Now that is done using HTTP protocol, and that's why these ones are called HTTP messages. So the user sends the HTTP request message, and then the server sends the HTTP response message. And that's how we exchange data on the web. And for the remainder of the course, we'll be responsible for building such web server using Node and more specifically Express. Now I'll talk about it why we use Express as well as show you a few examples later on in the course. But for now, just remember that yes, we'll use Node, but in order to make our lives easier, we'll use the framework by the name of Express.js. And lastly, I would just want to mention that even though name server definitely sounds way cooler than the computer, at the end of the day, they're just computers whose job is to always make that resource available. So yes, those are computers. And yes, there are some differences. For example, they most likely don't have the graphical interface or the GUI. And also, they're probably much bigger than your laptop. But at the end of the day, they are computers whose job is to always make sure that that resource is available. Because imagine if you would have a server that only works from 8 to 5. So if you go to your website at, I don't know, 6 o'clock at night, you cannot access the resource. Probably that's not the service that you would pick. So next time when someone asks you if it rains, does the cloud still work? You know what to answer. Because